Hey everybody, we are live here at Big Data London. Not technically live, it is pre-recorded, but
Well, we're here live.
yeah, we're here in person live, which is a rare thing these days. I'm here with Joe Reis, the guy in data. Joe, you've been doing so many cool things. Glad to run into you here. You recently had Andrew Ng on your show.
Yeah.
And Andrew is one of the great thought leaders in machine learning.
He's on the Mount Rushmore, as far as I'm concerned, yeah.
Yeah. So that was an awesome episode. You're doing a lot of great work in educating the masses on AI and machine learning as well. Yeah, just catch us up on what you have going on.
Well, it's funny, today we're announcing the launch of the data engineering specialization on Coursera. So I've been working with the fine folks at DeepLearning.ai and AWS for the last year on this. DeepLearning.ai is Andrew and his team, so yeah, drops today. Pretty stoked about that.
It's coming out today? Wow.
Comes out today, yeah.
And can anyone sign up?
Anyone can sign up.
Wow.
You could sign up.
Can I sign up? Okay. Most importantly, I can sign up.
Yeah.
Those who are watching this in person can probably sign up too. We can probably get you on the wait list.
Go to Coursera.org.
That's super exciting. So tell me about this specialization.
Well, so obviously Matt Housley and I wrote a book on data engineering a couple of years ago, and I really felt like that was a great intro to, I would say, the fundamentals of data engineering, but it was a very technology agnostic book that didn't go into a lot of code or any examples, and that was by design. I feel like a book really isn't the place to have code examples. Some people may disagree with me, but once something goes into print, it's sort of out of date already, so you want something that's going to last. We really felt like a course was like a real complement to the book, where you could give a lot of hands-on examples and I think dive deeper into material that you really couldn't get into in the course. So, so the course really, I think, is sort of the yin to the yang of the book. Covers the data engineering life cycle and the undercurrents, I think, but in a way that gives you like a lot of challenging hands-on exercises. So,
yeah.
I mean, even when I took some of the exercises and did it, the final versions, it's like, God, yep. That's legit.
So we know anyone who goes through your specialization, do they get a certification?
Yeah, you get a certification at the end by Coursera, yeah. Signed by myself and I think a few other people, so.
Excellent. So we know that people that go through Joe Reis's data engineering specialization course are tried and true at implementing data pipelines that can feed real world machine learning and AI operations.
And analytics.
Analytics,
yeah.
Still generally a lot of focus on analytics.
Yeah.
Your book, The Fundamentals of Data Engineering, big cornerstone. Everyone, I would say it's definitely on top shelf of my book cabinet for data engineering. Your book, along with Martin Kleppmann's book on design data intensive applications. And you mentioned yin and yang. I feel like those two are great yin and yang, because your book is so practical, right? You say all the things that data practitioners sort of need to know. People who've been on the job always read it and say like, okay, they kind of say the stuff that like is mostly unsaid, but everyone knows, like that, from learning on the job. So I always recommend it to people who are breaking in.
Yeah.
And then I recommend Martin Kleppmann's book for the people who are like, they do their jobs in analytics and engineering, but they don't know too much of how it works under the covers.
Yep.
Right? And now it sounds like with your specialization, your Coursera class, it's really for technical operators to level up and get certified.
Yeah, I mean, you could start from zero. I mean, the expectation is you might know a bit of Python. I think that's about it, not even that much. So it walks you step by step through everything. But yeah, it will take you to being at least like technically capable of doing stuff. I wouldn't say you'd like, kill it the first day of your job, but at least you'll know what you're doing. But I think that, so it's yeah, I think it fulfills that thing. And Martin's book's also awesome. I think that's sort of the, we originally wrote our book to sort of be the prequel to his book, where that was very much, I would say, throws you off the deep end into the innards of distributed systems, and I think that's a great book if you're working it. But what we also notice is like, not a lot of people actually do the low-level engineering that book tells you about, and I think it's great to know how things work. But if you're not doing it day-to-day, or for your, especially if you're more junior in your career, I think it needed to be sort of an introduction to being able to think about how to reconcile using those tools in production. So
yeah,
that's where we came in. And then obviously, Martin's working on a second edition of his book too, with Chris Rickman. He was like awesome engineer, so I'm excited to see what they're doing. I hope reviewing it.
Yeah. Sounds like he's updating his book to probably reflect more of the modern tools. His book, he mentions things like React that were more like, early 2010s, late 2000s open source tooling, but now there's been like this flood of tooling that's come in. And what I'm really excited about, especially for your Coursera class, is it's all coming together. I feel like the stack is sort of stabilizing, the tool chain is stabilizing.
Yeah, it is. It feels like that. I mean, if I look around, it's a lot of the same vendors from last year. So I think it feels like the vendor space is at least like stable, right? I don't see anything here where that's completely out of left field. There might be, I don't know. I mean, you have to walk around and see.
No, I agree with you. Yeah, I did a quick walk around. That's how I felt. It's like stabilizing. We're all sort of agreeing on what the layers of indirection are.
Right. What do you think about that, though? Do you think that that's a good thing, or do you feel like that's when the industry's ripe for its next inflection point?
No, it's a good thing for sure. I mean, if you ask my opinion, pre-COVID, there was your modern data stack. Modern data stack sort of blew up during COVID. You used so much funding, like billions of dollars of funding. All these unicorns came up. We all came back to conferences in 2022 being like, what the heck is all this stuff, right? And now it's sort of matured, stabilized. I have a good sense of what you should use now if you're trying to build a data or AI stack.
What do you think? Like, what would be John Coute's like stack of choice right now?
Yeah. So I mean, you got to have your cloud vendor. That really drives things. So I think that's sort of going to be your gravity, where you're going to decide is like your core. What tools am I going to use that are cloud vendor native, and then what things are like especially value add. So let's just pick AWS for instance. I'm going to obviously cold storage is going to be on S3. I'm going to use an AWS managed database. Now Oracle is on every cloud, so I don't have to, just because I'm on AWS, sacrifice having like a super performant, scalable database. And then Oracle has its own cloud now. So that's the other thing. Like the companies that were deemed legacy have actually modernized. They all have their own awesome cloud versions. And my stack of choice is, okay, start there, whether you're Oracle Cloud, AWS, Google Cloud, whatever. And then you're going to have your adjacent tools. So you're going to have your ingest products like Stream or whatever. I'm not going to name names, but you could probably guess some.
It's amazing, yeah.
Data modeling, right? You're going to have your DBT, or you're going to have your specialized data modeling tool. Then your analytics tool, which is also evolving quite a bit. So now I'm going to turn that question back to you.
What's my stack of choice? I think the stack that works for you, right? So I think like the only difference I would say is like I think nowadays I'm also seeing people sort of repatriate from the cloud, and that's often onto their laptop.
Oh my gosh, yeah, good point.
You're starting to see that because I think DuckDB is getting pretty awesome, so people I think are like maybe doing workloads there. So it kind of reminds me of what notebooks used to be back in the day, where everyone did local development on notebooks, and I think you're starting to see that now with DuckDB. Polar's another big one. I think that's an interesting one to look out for. But yeah, I mean, in the cloud, it's an interesting one. You could call it still the modern data stack, but I think we kind of move beyond that terminology just to the analytics stack. So
yeah.
But now everybody's also an AI vendor, so now that's one of the things I'll be talking about. Is sort of like the lines between analytics, AI, and even applications are blurring a lot.
Yeah.
And so I would say pick what works for you, because I think like the notion of where we're moving is changing as well, where it's like the tooling is mature, but now you know what you need to plug and play for certain use cases. What I'm looking at next is sort of what happens when these things start fusing into like data-driven products, AI-driven products, and it's not just about dashboards anymore or whatever. It's about like how do I power real applications to provide analytics to users that again provides a feedback loop to the app. And same with machine learning and AI, right? So I think that's that's the thing I'm most excited about is that. So.
And you cover all those core components really well in your book, The Fundamentals of Data Engineering. Right now, the other big thing, yeah, you mentioned people are moving workloads into their laptops, which is a great point. I'm actually going to be at Small Data SF run by the Mother Duck people next week, and that idea is like, okay, your laptop can store a terabyte of data and has hyper threading and multi-core processing, and you can do so many ad hoc workloads on your own machine without running up like cloud compute bills. So that's also going to be super interesting. But how do you still centralize and have like governance around it, not have like copies of data and things like that? I think
this is the big crux. I think we have to figure out what's the governance of the data sets that are created. That's why I'm talking about data modeling, Alex. I feel like if practitioners can't understand how to use these various forms of data, we moved beyond tables, right? Semi-structure is even an old story, but now it's about text, even images, video, audio, and how do you blend all these data sources together? Even Mike Ferguson was talking about it during his keynote, where it's like you're going to be doing analytics and combining that structured, unstructured data sets. I mean, it's been happening at some companies for a while, but this is sort of I'm excited about. But then you got to know how to handle all these different data sets, right? Like, if you think that everything needs to be in a table and you approach everything from a relational modeling standpoint, and you're dealing with images, I don't know what to tell you. Or even nested data, right? Semi-structured data, that's a first-class citizen in almost every database now. Yeah. But does that would definitely violate the third normal form relational model, because you can't have nested data. Every row has to, so it's like, so how do you reconcile all these concepts together and create data sets that make sense, not just for you, but for other users? Because if you're working in a decentralized world, the data ideally has to have some useful form and shape, right? So it's been on my mind a lot, like how do you make this work in a decentralized, because I think decentralization is sort of I think that's the goal of, even now, right, Zermatt talked here 2 years ago, and they still hear conversations on data mesh, data fabric, and everything else, and that conversation isn't going away. I think that's an ideal that everyone wants to get to, but ironically, the centralization is sort of, a centralization of standards and the federated computational governance is sort of how you're going to get there. So it's almost a paradox in a way, right? But in a centralization of practices, or at least an understanding of cross-team practices to make it work. So it is interesting.
That part, every organization has to figure out what decentralization means to them.
Yeah.
We'll talk tomorrow with National Grid on how they've decentralized their analytics with data products. And there's always this sort of messy middle where you can't just like read a book and say, this is how we're going to do decentralization. I think it's like trying to fit a round peg into a square hole. So what are your recommendations for teams that are trying to go down this journey of decentralization? And
I think you hit it though pretty clearly. It's like you got to understand, what does that mean to you? Because inevitably you're going to run against Conway's law, especially when you're in your own organization. So Conway's law describes that you'll design systems according to the way that your company communicates. So if you're very siloed, the systems you build are going to be very siloed. And so that's one of the cruxes, is really understanding, in your organization, what's a tolerable level of decentralization, or is it tolerable at all? That's the other thing. Maybe you don't need to, because it's physically impossible anyway, so you may as well not lie to yourself, which I think a lot of companies do, because they're like, oh, we got to do data mesh. I'm like, yeah, there's no chance in hell that'll ever happen at your company, because everything is very rigidly hierarchical and siloed, and it wouldn't work.
Yeah.
The very org structure is like the epitome of centralization.
Yeah.
So it's the inviolable rule. I talk about, there's sort of a corollary that I jokingly called Reis's law, which is you'll design your data models according to Conway's law and the architecture that supports the company, and so it's interesting.
I think Joe's law, that's certainly something that everyone needs to coin at this point, and I agree, exactly. The way you do data modeling, even the way you name your tables, is like a reflection of how your company operates. Like, are you really truly meant for scale where business users can go click a button and get some insight, or are you always going to go need to ask the data engineer to kind of decipher and decode and prepare data for you?
Oh yeah, I've seen it in some companies where they, one company I remember they were using still a 1980s era mainframe, and they're like, oh, we're going to decentralize. I'm like, no.
Yeah.
Not until that thing's gone. But you had to design all your architecture according to what that database, how it was designed back in the day, and you had 7 or 8 character limit columns, and it's pretty awesome. So I'm kidding. But that's the reality of a lot of businesses, right? You have a lot of infrastructure that needs to be revamped, and that's okay, you're just going to gut all that today and go move to something else? No, that's not how that works.
Yeah.
So that's just the reality of it. So I guess to answer your question, it's what does that mean to you? And you got to look at the cold hard facts of what can we support?
Yeah.
Right. So
as of the time of this recording today, you have a keynote here at Big Data London. What are you going to talk about?
I'm going to talk about mixed model arts. So I'm a big MMA fan, mixed martial arts fan, have been for a long time. The notion is really that, we're still, the data world is in a lot of ways, I think we're moving forward. I think AI was sort of the kick in the pants that everyone needed to sort of move on. But the discussions have been, you watch Napoleon Dynamite?
Yeah.
Remember that character Uncle Rico, the guy who was living in the past when he almost won state for football in high school?
Yeah. He could throw a ball over the mountain.
Over the mountain, right. That's what I feel like a lot of the data industry is. I feel like we're Uncle Rico, where we're just reminiscing about the past. And we're just stuck in the 80s and the 90s. In data modeling, this is true. People, when you mention data modeling, people still talk about relational. It's oh, you mean Kimball or Data Vault, right? We're still stuck in this tabular world.
Yeah.
Nothing wrong with that, but it works for what it works for. But the thing is, applications, NoSQL is around 20 plus years already, right? And streaming is another thing.
Yeah.
Right? Are any of those tables sort of not? There's a blend of data. Now we're introducing text.
Yeah.
All this other stuff into it. So it's the notion of mixed model arts is about adopting what works across disciplines, machine learning, analytics, and apps. Because what's happening is there's a convergence happening of all these disciplines as we speak. When you open up Uber, right? I think at one point when it started, that was a Rails app actually, but now it's if you look at the number of Kafka events it brings in, a number of other things, it's insane how much data this thing ingests, and it's a data-driven app that also uses machine learning. All these things work together seamlessly, but this is the direction products are going.
Yeah.
So it's a recognition that there's more than one way to think about and model data, but you have to know all these things. And increasingly, especially when we live in an era of constraints, budget cuts, teams are more asked of people, whether you're a software engineer, whether you're data and analyst, scientist, you're going to have to become, I think, full stack with your data modeling skills. So that's the notion of the talk.
That's incredible. And does this tie seamlessly into your certification?
Somewhat. So we do talk about data modeling, and we do talk about all these use cases across different, so we talk about analytics, machine learning, even working with application data in the course for sure. Yeah. So I feel like this is one of those things where you just need to understand all the different ways of handling data. It's sort of mixed martial arts, right? When we talk about that, back when I was growing up in the 80s, it was well, what would happen if Mike Tyson fought Hulk Hogan or something, very one-dimensional fighters, but nowadays, it's mixed martial arts. If you took anybody from the 80s or 90s and threw them into the UFC today, they would get mauled in about 5 seconds. Because it's a very cross-disciplinary sport, and this is the same way I feel about data, where we need to catch up to where reality is instead of dwelling on the past and thinking there's, I think it's saying fixated on the old approaches.
I always quote you specifically on this when you talk about, okay, what direction is data going in, and look at software engineering, right? Because the more I find really good productive data engineers and people who work with data stacks have the skills of a software engineer. And if you hire a software engineer, they can probably learn that pretty quickly, right? They could probably take your certification, read your book, and just hit the ground running and build these scalable, fault-tolerant data pipelines. Whereas if you hire someone who's too specialized just in analytics engineering, their only knowledge is SQL, right? They have to work in a very narrow scope, which ultimately makes it hard for them to be successful. So, I always mention this to folks: data engineering is software engineering, but it's specialized software engineering. I think your point about mixed model arts, where you'd have to have this multidisciplinary skill set, and ultimately, that's what being a software engineer is. You can't be a software engineer who just says, oh no, I only use like this one part of one language, and I don't deploy it, I just write the code. Like, no one thinks like that, right?
I only write struct.
Yeah, I only write structs, just for loops.
No, but I always felt like, if you were to take the mixed martial arts equivalent of software engineers, I always felt like software engineers were the wrestlers, or if you were to pick like one discipline, if you knew nothing else and you were to go into martial arts, like wrestling, you can dictate where it goes. You can keep it standing up, you can go to the ground, and like, I feel like as software engineers, you have the chops to sort of dictate where things go, because you have the technical ability to deploy things in production. That's unlike analysts that just make dashboards. Nothing against that, but it's just a different skill set. But I feel like, again, with the way everything's going, it's like a lot of these skills, what I notice is that my software engineering friends, not a ton of them, but a lot of them are interested in analytics and machine learning. It's like, I need to start bringing this into my stack now.
Yeah.
Right? Like, especially ML and AI. It's like, this is like the stuff that you weren't talking about, but now everybody, a lot of software engineers are conversant in vector databases, for example, right? That 2 years ago, that wasn't even a conversation piece.
Right.
So now they're expected to bring in all these different workloads. Like, I need to bring in, either make an OpenAI plugin call or something, but it's like, different world.
One thing I am really impressed with is just how ergonomic the cloud providers have made, using an LLM and, just integrating into your same cron jobs that are doing like data processing and data modeling and transformations. I can go into like Vertex AI's, Google Vertex AI's model garden and go pick like, Anthropic's models or Gemini, AWS as Bedrock, and it's super integrated. So and I just did a talk here right before this with Cramp, which is an amazing company. They supply a lot of the parts for agriculture companies in Europe. They operate at tremendous scale, and they've already adopted AI and machine learning, not because like they were just super gung-ho on doing AI, but they were like, this is the next practical step to make the experience better for our customers.
Bingo. And that's just it. It's about making experiences better, and so that's what a lot of these products do. Better chat interfaces, for example. It's like, that's the low-hanging fruit, right? Okay, but then what does that depend on? Well, it depends on probably training on some text data that you have, right? Got to know how that works. So yeah, it's an exciting time. I feel like that's really the inflection point that we're in right now. Is it's like, I think the stack stabilized, but then, now it's about adopting, new approaches to solve new types of problems, not just shoehorning the existing stuff to solve old problems. I think we've done a good job at that. We've solved a lot of those problems. At least from a technical standpoint. I still think the people process technology arm is always in the picture, and that there are always challenges, but I think from a technical aspect, when I look at the vendors here, it's like, it's hard to find like a tool that you would say like, that's a really bad tool. I mean, there's a lot of great tools these days. I mean, the bar is very high. Competition's intense. So now it's time now that you've solved a lot of, I'd say the pretty standard problems, now that pie widens, right? And now you can solve more problems. So.
Yeah, absolutely. Joe, you're the man in data. That's the best way to describe you. You're also author of The Fundamentals of Data Engineering. We'll have a link to that book down in the show description. Also his new Coursera class. Joe, have a great time at your keynote today. I'm definitely going to be there. I'll be your biggest fan.
Thank you.
In the back. Maybe heckling, depending on what you say.
You should, yeah.
Joe, great to see you. Thanks everyone for tuning in.